Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. We meet again in the third video. I will introduce you to two techniques in partial derivative. Okay, so the first one will be implicit function. Okay, and the second one is the chain rule. Okay. Let's have a function f which is independent of depending on a variable x and y. Okay, where given this function is equal to c, where c is a constant, so it can be 0 or it can be any other number. Alright, so this is the concept of implicit differentiation, similar as we apply in the chapter 4 for differentiation of the implicit function. That function must be equal to some constant, right? Just that when we apply partial derivative, there is a formula in order to find the dy dx, okay, the implicit differentiation, because we are now depending on two variables, which is x and the second one is y. Alright, so we cannot perform as a normal or common differentiation. Okay, right, so in order to apply partial derivative, what we do in order to find the dy dx term, okay, you need to partially differentiate your function with respect to the first variable. You divide with the partial derivative of the second variables. Okay, you have negative here, don't forget. Or you can rewrite this as del z del x multiply with del y del z. Okay, so you need to, if you use this formula, you need to invert your partial derivative of your dz dy. You need to invert this, okay, to del x del z. Alright, if you use the formula by using division as written here, you just put dz dy. Okay. Okay, let's look at the example here. Assume that y is a differentiable of x that satisfies the given function. Then you need to find dy dx by using the implicit differentiation, okay, by using partial derivative. Okay, so here this function, okay, this function is equivalent to 3. So you have the x, you have the y. Remember, when you apply partial derivative, you will treat the other constant that you are not interested to differentiate as a constant. Alright, so formula given that if you want to find your dy dx, this is equivalent to negative of del z del x over del z del y, or it is equivalent to negative del z del x multiply with del y del z. Okay, you can use any of these two formulas. Right, so let us do for this one. Partially differentiate this function, okay, del z with respect to x first. Okay, so this one will become 2x exponent for y plus with this x become 1, so you have 3y only. So this x will give you negative 6x square, and this constant will be 0, so minus 0. Don't write it. Okay, so Next, del z with respect to y. By using the same function, now concentrate on the y term. Okay, so x will be constant, so you will have that term. So exponent for y, differentiate for y, you will get 4. Okay, and then the second term here, you have y here, so that will give you 3x only. So for this third term, you would have no y, so that will be 0, and same goes to 3, will be 0. So this is your del z del y, and del y dy dx is equivalent to negative. Okay, so don't forget the negative one. Del z del x first, which is 2x exponent 4y plus 3y minus 6x squared over del z del y, which is 4x squared exponent 4y plus 3x. Okay, so this is equivalent. If you apply this formula, you will get the similar answer where it is negative. What is del z del y del x? Del z del x is 2x exponent 4y plus 3y minus 6x squared, and then you multiply with del y del z. So this is del z del y. You need to invert this if you want to find del y del z. So this will give you 1 over 4x square exponent for y plus 3x. So multiply that in here. You get the similar answer, 3x. Okay, so same. Right, so for the second example, we do it in the next slide. Okay, so we have done with this part, this question, where we find for del y del x. Okay, so you get this answer, right? So next, move to the second example. Right, for the second example, you have this is your z, right? So you need to, in order to find dy dx, you need this and this. Alright, so since in your function, okay, here, for the first term here, when we differentiate with respect to x only, you have two x's in here. You see? Same goes to this. You have 1, 2. 1. Okay, so this is 1. This is fine. This will be differentiated as usual. But for the first and the second term here, you need to apply product rule. Okay, this is similar as what as I shown you in the first part. Alright, so you need to apply product rule here and here because it involves with multiplication of two function here. Okay, two polynomial function here. That's why for the first term here you got these two summation because it came from the product rule. Same goes to this the second term. Okay, x times with sine xy, this will give you this summation. Okay, and this will be differentiated as usual, which give you 2xy. Y is a constant. Okay, treat as a constant. Okay, so same goes to del z del y. Whichever involved with two multiplication of 2, you need to apply the differentiation technique, right? Since for y, you don't have to worry because it just involved with 1 here, 1 here, and 1 here. So you will differentiate this by using normal partial derivative. So you got this, right? And then apply into the formula, you will get this answer. Okay, so done with the implicit differentiation. Now we're going to move to chain the rule. Okay, so let z be a function of two independent variables x and y. So x and y are independent of each other, but function z here depends on two variables, which is x, and the second one is y. Alright, and you have the second function, which is y. You have a y, your x, okay, your variable x and your variable y are function of two independent variables u and v. So can you imagine this? You have a function, okay, which is depending on two variables x and y. Okay, but at the same time, your x and your y are also a function, okay, which are depending on other variables u and v. Okay, so in order to find the partial derivative of your z with respect to u, you need to apply this formula. And alternately, to find the partial derivative of your function z with respect to v, you need to apply this formula. Okay, so you don't have to remember this. You can refer to your textbook since you will be tested by using open books test style, right? Okay. Oh, in addition, the concept of chain rule is you will multiply two partial derivative like this. Okay, so you have del z, del x, and then multiply with del x, del u, so that you will cancel by right. Okay, you cancel del x, that will just leave you with the term del z, del u. This is what you want, del z, del u. Since you have this is function which is depending on more than one variable, so you need to consider the summation of other partial derivative. So if you have two, you have to sum with the partial derivative of other two, which will cancel the term here and leave you with the del z, del u. If you have one more variable, you will do the same. We consider del z, del w, for example. This need to multiply by del w, del u, cancel this and that, just leave with this and continues if you have more. Alright, same goes to del z, del v. You must make sure that the last term will just leave you with del z, del v when you cancel the variables. Okay, and so on. That is the concept of chain rule. Let us look at this example. Okay, this is what I mentioned before. I explained before in the first slide, where you have a function z. Z is depending on two variables, x and y, x and y. While at the same time, your x and your y are also a function with respect to u and v. So x is also a function. Okay, so in here it has function x, which is depending on the first variable u, and the second one is v. Okay, same goes to y. Y itself is a function where y is depending on u and v as well. Alright, so when you deal with these kinds of function, right, you can apply the chain rule in order to find del z, del u. Okay, if you substitute x and y in z, you will roughly look at like this. 2, what is x? X is 2u squared, v plus 3v, and then multiply with u anymore, 2u v3 plus u. Okay, plus with exponent of 2x. What is x? X is 2u2 plus 3v. Okay, and then multiply with y, which is 2u3 plus u. Okay, so you see here how complex your z is. Alright, if you rewrite your z in terms of u and v, so we just simplify the writing into x and y function. right? So that it looks more nicer and tidy. Okay, more nice. It look nicer and neat and tidy. Alright, but at the same time, you must remember your x and your y are two functions that is depending on u and v. Okay, that's why here we are interested to find del v del u because del z del u because our z here in reality in fact it is depending on u and v. Okay, not x and y. Alright, that's why we find this. And same goes to this. Don't forget in z here we have variable v. We have variable u, the final product of your z. Okay, so since we have represent u, v here by using function x and y, so that's why we need to apply the chain rule. Okay, this will be differentiating del z with respect to your x. Okay, you have x here, right? But you need to multiply with del x, del u. Okay, where this will cancel the x and the x, so just left with del z, del u. Okay, don't forget z has one more variable which is y, so del z partially differentiate with respect to y and that differentiate your y with respect to your u. Okay, so you will get del z del u. Same goes to del z del v. You need del z del y and del y, sorry, del x, del z del x times del x with respect to v plus del z del y multiply with del y del v. Okay, so that will give you the answer. So it means here that this one for z you need to, for z here you do for del z del x, find del z del y, and for x you need to del x del u, del x del v. Same goes to y here, you need del y del u, del y del v. Once you get what is their partial derivative, okay, then just substitute in. Okay, right, so for each function that we have z, x and y here, I found their del z del x del y, del x del u del v, del y del u del v. Okay, this will be substituted into the formula. Okay, once you got your partial derivative of each of the function, then just substitute and ta-da, you got the answer. Okay, I don't show you on how to do the partial derivative because we have done a lot. Okay, I've shown you a lot and it is easy to perform partial derivatives. So just check your calculation by using mine here. Okay. Okay, that's it for the two techniques involved in partial derivative, where you can apply a partial derivative in order to find the differentiation. Alright, see you in the next part. Thank you very much.